Now in question 16, you're asked to produce a graph using your graphics calculator and then to do the sketching. I'll show you how to do this on the graphics calculator, but we'll leave you to sketch it. You've already seen how we can produce graphs using your very powerful graphics calculator for this. So I'm just going to swap it around. And we've got the following equation. AN plus 5. And our initial term, our first term, sorry, is 20. Select, generate the table. You must always generate the table before you can have a look at the graph. And looking at the graph, you pull that down there, you can see the terms generated. For a bit of sanity's purpose, I strongly suggest that you just graph from 1 to 6. So when we do that, I've staggered my axes, you can see that we've got a classic arithmetic sequence in our first question. And just record the graph with the staggered axes. Now in part B, you're asked to produce the graph of Tn minus 5. So I can simply overtype here, and the first term, is 10. Generate the table. The table must be generated. Now, a few of my students in the past have found it just as easy to generate the graph straight off the table, but the graphics calculator is pretty neat for these things. Just slide it up there, and you can see the terms generated and graphically. If you want to, the trace function is particularly good in this instance. You can tab through the points generated. For sanity's purpose, simply graph through to the first 6 points. So record in the table and then transfer it to a graph. When it comes to part C, you've got a classic geometric progression starting at 6. Be a little bit cautious how you graph this, as it does start to head off in a very sharp exponential direction. You can see my graph there. I'd have to rescale that a little bit in order to get 6 terms in. So reminder, I'm happy with my X, that'll be fine. I'm going to make my maximum there around about 2000, fit everything in. And you can see the graph heading upstairs like that. When it comes to graphing it, table and data for n is equal to 1 to 6. I've suggested going 500, 1000 and 1500 there. That will help you scale it. Part F is of a difference equation, a recurrence relationship where we have both a common ratio and a difference. When I enter the data for that, you can see 100, 185 through to 2735. And when I press the graph there, because I've had it from a similar function before, you can see the first 5 terms are generated pretty readily. If I wanted to adjust my graph so I can see the scaling a little bit more sensibly, I might make that 500, and I might actually move that to 4000. So I get all my points in. And you can see the grid starting to appear. That trace function, which you should be familiar with from another unit, is pretty neat. When it comes to graphing it, record the first 6 data points and scale a graph accordingly.